Hey everyone, and welcome. If you're a Swift developer, you're constantly making choices that shape how your apps are built. And today, we're going to break down one of the biggest architectural decisions you'll ever make: inheritance versus composition. So let's get right into it. And look, this isn't just some nerdy technical detail. The choice you make here, it has a massive impact on how easy it is to scale, change, and maintain your code later on. You're basically deciding on the foundation of your app. Is it going to be solid and flexible, or is it going to crack under pressure when you need to add new features? All right, first up, let's tackle inheritance. I think the absolute best way to picture this is like a family tree, where kids inherit traits and characteristics directly from their parents, who inherited them from their parents, and so on. So what this really boils down to is creating what we call an is-a relationship. A more specific thing is a version of a more general thing. This means the child's class, or subclass, it just automatically gets all the stuff, the properties and methods, from its parent. Let's actually see what this looks like in some code. Okay, so here we have our parent class animal. Super simple, right? It just defines one single behavior that pretty much all animals share. They all eat. This is the top of our family tree, the ancestor. And now we create a dog. See that little colon after dog? That's us saying a dog is an animal. So right away, our dog gets that eat method for free without us writing any extra code. And then we add its own special skill. It can bark. It's a specialist that builds on the generalist parent. Okay, so here's the deal. This top-down structure has some serious trade-offs. It's awesome when you have a really clear, stable hierarchy. I mean, think about UKit. A UI button is a view. That makes total sense. But it becomes a huge problem when you force these relationships, creating these deep, tangled family trees that are super rigid. A tiny change at the top can cause a huge mess all the way down. That's what we call tight coupling. Everything's kind of chained together, and it makes your code a real pain to change. All right, now let's completely switch gears and talk about composition. This is a totally different way of thinking. If inheritance is a family tree, I want you to think of composition like a box of Lego blocks. You're not inheriting traits, you're just picking and choosing the pieces you need to build something new. So instead of that is-a relationship, composition is all about has-a or can-do. We're not focused on what an object is, we're focused on what it can do. We build our objects by grabbing these independent, reusable capabilities and snapping them together. Check this out. Here's our first Lego block, a protocol called Flyable. This protocol just defines a single capability, the ability to fly. It's a self-contained little skill. Anything that wants to be able to fly can just say, hey, I'll take that, and adopt this protocol. And here's another one, Swimmable. Now notice, this has absolutely zero relationship to Flyable. They don't know about each other, they don't care about each other, they're just two separate tools sitting in our toolkit waiting to be used. And bam! This is where the magic really happens. Look at our duck class. It's not stuck in some rigid family tree, it just reaches into our toolkit and says, yep, I need the Flyable capability, and I'll take the Swimmable one too. It literally just assembles the exact behaviors it needs. It can fly, and it can swim. How cool is that? So you can probably see why this mix and match approach is so powerful. It's incredibly flexible and modular. You don't have that rigid hierarchy locking you down. You can combine behaviors in all sorts of new and interesting ways, which at the end of the day just leads to a much cleaner and more adaptable code base. Okay, we've looked at the family tree of inheritance and we've played with the Lego box of composition. Now, let's put them head to head, a real showdown to make the differences crystal clear. This table pretty much says it all, right? With inheritance, you've got that vertical is-our relationship. Behavior flows straight down the family tree, which is powerful, but not very flexible. With composition, though, it's a horizontal can-do relationship. You're picking behaviors from across a toolkit, giving you way more flexibility to adapt and change things later. So, what's the verdict? What does this actually mean for you when you sit down to write your next app? Which one should you reach for? Well, the general wisdom in the Swift community points to a very clear recommendation. And here it is, the key takeaway. Favor composition over inheritance. Why? Because it generally leads to code that's cleaner, easier to scale, and way easier to test. And this is especially true in Swift because our language's powerful protocols are the perfect tool for creating those reusable Lego block capabilities we've been talking about. What this all comes down to is a simple idea: build for change. When you're designing your app, don't just think about what it does today. Think about what it might need to do a year from now. Building with composition is all about building that flexibility right into the DNA of your code from day one. So there you have it, two incredibly powerful tools for your developer toolkit. One gives you structure, the other gives you incredible flexibility. And honestly, knowing when to use each one is what separates good code from truly great code. So the only question left is, now that you know the tools, what are you going to build?